Good morning, my dear students, and a warm welcome to the geography lecture of your 8th standard. I, Sir Sylvester D'Souza, will be continuing with the lesson what I had started in your geography in the previous lecture. That's on last Wednesday. So, students, this is your table of contents, and we had started with the first lesson, that's local time and standard time. Okay, that comes under the category called as general geography. Okay, and that's on page number 1 of your textbook. So, this is page number 1. And while doing this, students, I hope you remember that in the previous lecture we had completed with this page number 1. Okay, we had completed with this entire geographical explanation part of this. Okay, and then we had discussed about this figure 1.1. So here we have the figure 1.1. So students, basically in this figure we were trying to see and understand the various effects of the sun apparently moving from the east to the west. So what are the various effects, and effects on what? On this pole what is put in the middle of a open ground. Okay, so in short, students, you have to put a pole on an open ground and you have to learn and observe the shadows that are being created because of the movement of the sun from the east to the west. Okay, so if you see the movements, my dear students, you might have understood that as the sun is moving from the east to the west, we can say that the shadow size is being changed, okay, simultaneously. In the morning we can see at 8 a.m. it's the largest over here, it's the biggest. Then it becomes a bit smaller at around 10 a.m. and then at right at noon, that's at 12 o'clock in the noon, it is the shortest. Okay, then again in the afternoon at around 2 o'clock it becomes a bit bigger, and then again like morning what we see at 8 a.m. the same we can see in the evening at around 4 p.m. Okay, so these are the various effects of what we had seen on the shadows due to the apparent movement of the sun from the east to the west. Okay, next let us move to the geographical explanation. You would have realized by observation that the shadows in the early morning and in the evening were the longest. Okay, so I said just now that those in the early morning at 8 a.m. and those in the evening, that's at 4 p.m., were the longest. Okay, so they were the longest, while those in the noon were the shortest. That means that was in the afternoon at around 12 p.m. this was the shortest shadow. Okay, so we have seen that. Then because of the change in the apparent location of the sun in the sky, so why can you see that the length and the direction both of the shadow is changing? Okay, why? It is only because of the apparent movement of the sun. Okay, so it's only because of the apparent movement of the sun that you can see a difference in both. You can see the difference in the direction as well as you can see the difference in the length of the shadow, okay, of the pole that is kept. So you can see this again over here. Okay, east the shadow is towards the west, in the west the shadow is towards the east. Okay, so it keeps on changing. Okay, next, this is because a specific part of the earth faces the sun during rotation and moves forward. So why is it? It is only because a specific part of the earth, okay, when you can see over here. Okay, just let me just show it to you. I have the image. Okay, see here it is. You can see that during the entire earth, this is the entire earth. So this is the specific part, this lighter part, what you can see, it is facing the sun, whereas the other part, this part, what you can see, midnight return over here. Okay, this is coming at the opposite side of the sun. Okay, so this is all because of that changing position. Okay, now incidentally we also experience that it's cooler in the morning and evening and warmer in the afternoon. Now everybody would agree, in the mornings at around 8 a.m. and in the late evenings you will see that it is cooler, but in the afternoon and at around 12 p.m. it's really very very hot. Okay, it's scorching hot. Okay, so here again one more image I'm showing you how the sun rises in the east, then it moves. Okay, there is an apparent movement and then it moves towards the west, and then there we have the sunset. Okay, now we are going to study about a new topic, okay, or in fact a new thing called as a local time. Okay, it's a bit difficult while you read it, but when you understand it, it's very simple. I suppose most of you all might have understood also what you mean by local time by the explanation that I have given you up to now. Okay, now let us use this figure 1.2 for understanding what do you understand by local time. As soon as the sun starts moving up in the sky after sunrise, the length of our shadow reduces. So just now you saw that in the image, as the sun is moving upper in the sky, the length of the shadow also reduces. Normally the length of the shadow is the shortest in the noon. So the same thing is repeated again, that is the shadow, okay, in the afternoon is always the shortest, okay, and those that you see in the morning, okay, those that you see in the morning and those that you see in the evening, my dear students, they are much longer when you compare them with the afternoon shadow. Okay, as the sun moves towards the horizon in the afternoon, the length of the shadow increases again by evening. So just now I told you, morning it is very large, noon it becomes shortest, and by the time evening again it comes, okay, by the time evening is coming, again the shadow increases. The noon time is the same at any given longitude of the earth, that is from the north pole to the south pole. Okay, so I'll tell you what do you mean by this. Now students, we have got imaginary lines on our planet earth. Okay, we have got imaginary lines. These imaginary lines, my dear students, are called as longitudes and latitudes. See here, you can see them. These, what you can see, which are longer in size, okay, they are called as longitudes. Okay, and those that are moving from up to down, that is from north to south, are called as longitudes, and those that are moving from east to west, they are called as latitudes. So longitudes are long this way. Okay, now let me go to the other image what I was showing you in the year. Okay, see here, we can see that. Okay, now all these longitudes, what are there? Okay, all the longitudes, this longitude, say for example, the noon time will be the same, because from here, from the north, when you come towards the south, this longitude is facing the sun. So whether there is any place situated over here in the north or in the middle over here or in the south, it will be always having the same timing. Okay, now therefore, if you see the last sentence, the time of a place is decided by the location of the sun in the sky, and it is known as local time. So students, whatever timing you are seeing, okay, whatever timing you are seeing on your watch or on your clock, okay, it's only because of the location of the sun in the sky. So always remember that. So whenever you can see the location of the sun in the sky, by that we can determine what would be the local time of that particular place. So local time is basically the time of a particular place. Okay, so that is called as the local time. Okay, now here we can see again that this part the sun is there, and this much area of the earth is called as noon, and the other area it is called as night or midnight. Okay, and we can also see the moon also is moving over here. You can see the moon over here. This is also moving around the earth. Okay, it's also moving around the earth. Now once again, the definition, the local time of a place on the earth. Local time meaning time of a particular place, okay, on the earth's surface is determined with the reference of its noon time. So basically, first we always determine the noon time when the sun, okay, is right above the earth. Okay, that means it's 12 at noon. Thus the time of the place as decided by the location of the sun in the sky is called as local time. So the time when the sun is right on top of the earth, it's called as noon. And then once we come to know it's noon, then we can decide what is the local time of that particular place. Okay, next, in the regions lying between the polar circles and the poles, the daytime could be more than 24 hours depending upon the season. Now let me tell you over here. Now my dear students, always remember, our earth axis is not straight. You can see your earth's axis written, it's a bit slant. Now because of being slant, my dear students, you can see this area over here, this area of the earth sometimes faces darkness, basically near the pole. This is the north pole and this is the south pole. Okay, so basically near the poles, if you see, my dear students, we can understand that there is 6 months of darkness and 6 months of light. Okay, it's only near the poles. Okay, as a result, understanding of the timings of the sunrise, noon, sunset and midnight at these places becomes important. at the poles. I'm talking about the poles, that's the North Pole and the South Pole. The daytime and the duration of the day last for around 6 months. Just now I told you, you can see this. Now here this North Pole is facing what? Completely light, and this light will be for 6 months, whereas over here, my dear students, the South Pole is facing darkness, and this darkness will be again for 6 months. So basically 6 months of light and 6 months of darkness. To tell the time around the sunrise or sunset at the poles, one has to consider the date. So whenever you have to talk about the sunrise at the pole or the sunset at the pole, we have to see the date. Okay, when the sun rises on a specific day, it moves around the horizon, and therefore here the length of the shadow cannot be considered for telling the noon time. So basically the main reason over here is, here we cannot decide. Now just because the sun is facing over here, it does not mean that here there is a daytime. We can see that this area is in darkness. It's only because of the tilted position of the earth. The earth's axis is a bit tilted. This is straight. Okay, this line you can see over here, this line is a straight line. Okay, this line is a tilted line. You can see this dotted line over here, tilted, meaning it is not straight. Okay, this line is not straight. See here, you can see it much more clearly. This axis, this is the axis of the earth. This is a crooked line, a tilted line, whereas this line over here is a straight line. So due to this, we can see many a times that the apparent location, okay, the apparent location of the earth, it feels like it's being tilted. Okay, now different longitudes have different timing for sunrise, noon and sunset. While it is noon at Mumbai, it wouldn't be the same at Kolkata, because Kolkata lies to the east of Mumbai. It would have already been afternoon in Kolkata. Now both these places, Mumbai and Kolkata, my dear students, are coming in India. They are places of our country, India. Now, in spite of being the places of our country, India, though we all of us follow a standard time, I'll teach you about that. It's called as IST, that's Indian Standard Time. Though we all of us study about it, that's the Indian Standard Time, my dear students. But still, if you see the exact time, if you want to know the proper time of any particular place, we should always look at the sun, which is in the noon, and we know that Kolkata comes to the east, okay, eastern part, whereas Mumbai comes to the west. So of course in the east the noon will be first, which means that it would be afternoon first in Kolkata, and then it will be afternoon in Mumbai. Okay, but I told you, at present we all, okay, that is all over the country, India, we all of us follow only one timing, and that timing is called as the Indian Standard Time. It's called as the IST. Okay, the local time of a place on the earth's surface is determined with reference to its noon timing. So just now I told you, whenever I'm talking about the timing of the earth, okay, I always talk about the position of the sun. So what's important for me is the position of the sun. Okay, what's important for me is the position of the sun. So once I determine the position of the sun, my dear students, at that time I can determine what's the time of that place at local time. Okay, this implies that the place lying on the same longitude at the same time. I just showed you with the image that all the places lying on the same longitude always have a same time. Longitudes are lines passing from north to south. Okay, there is no difficulty when local time is used for a small area. Okay, so whenever we are using local time for a small area, my dear students, we don't face much of difficulties. But this becomes difficult whenever you are talking about places which are huge in size. Okay, places or countries which are having a huge size. Okay, when the people live in a large area across different longitudes and have to interact with each other, then using local time could lead to chaos and confusion. Now imagine if Mumbai and Kolkata both had different time. Say for example, if it would be 8 o'clock in Kolkata and it would be 5 o'clock in Mumbai. Now if somebody tells you I'm leaving Kolkata at 8 o'clock and I'll be reaching Mumbai at 5 o'clock, what will you say? Which 5 o'clock? Kolkata 5 o'clock or Mumbai 5 o'clock? So there would be a lot of confusion and chaos. Okay, somebody says I sent money to you yesterday at 6 o'clock in the evening from Kolkata. Okay, then you will see what is 6 o'clock in the evening. 6 o'clock Kolkata or 6 o'clock Mumbai. Okay, so that is a big problem. There would be a lot of chaos. Chaos meaning problem and confusion. So in this time, so in these kind of cases, okay, using the local time is not convenient. So we can understand that in these kind of cases, my dear students, using of local time is not possible. Okay, so therefore at that time we have to follow something called as the standard time. Now students, I would like to tell you one more thing. I told you these are longitudes, these are latitudes. Now the most important latitude, my dear students, is called as the equator. This equator cuts the earth right in the center this way into two parts. This part is called as northern hemisphere and this part is called as the southern hemisphere. And the longitude, very important longitude, is called as the prime meridian, and that again cuts the earth into two parts. This is part number 1, this is part number 2. Okay, this is called as the western hemisphere and this is called as the eastern hemisphere. So whenever if anybody asks you which is the most important longitude, you will say prime meridian. Which is the most important latitude, you will say it's the equator. Is it clear? Okay, so here again we can see that it is moving from the west to east direction. Okay, the earth is moving from the west to east direction. Okay, now the earth almost takes 24 hours to complete one rotation, that is 360 degrees. Okay, 360 degrees. Now if you divide 360 degrees, that is the entire circle's area. Okay, it's almost if you divide it by 24, we have 15. Okay, in 1 hour, that means 1 hour will be 15 degrees. Okay, that means the earth takes about 1 hour to cover 15 degrees. Okay, and then 1 hour meaning it is almost 60 minutes. So basically if you see, it takes almost 4 minutes to cover 1 degree, which means there is a lot of time. Okay, lot of different times within the country, but we all of us at last follow only one timing, and that is called as the local time. Okay, now students, today we have discussed about local time. I want you all to revise everything. Okay, by tomorrow or day after tomorrow I'll be sending you the notes also. Okay, very soon we'll be starting with our practice test also. So students, I want you all to start studying now. Okay, I'll be sending you the objectives only. Okay, please start studying with the objectives. Okay, is it clear? If anybody has any doubts, you can drop a message to me, okay, on my number. If you have understood everything, very good, my dear students. Okay, stay home, stay safe, take care of yourself and your families. God bless you all, my dear students.